This video is going to cover some basic math methods and how you can just do some math operations like a calculator, basically. And I've made a list of the ones that I'm going to cover here. And so let's talk about abs. Abs is absolute value. And from mathematics, absolute value means basically whatever the number is, just make it positive. So before I do it, I need to create some numbers here. So I'm going to have an integer a will equal, let's have one positive number like 5 and one negative number like -7. Alright, now to do abs, what I'm going to do is I'm going to add an output statement, and I want an absolute value. Let's take b, because b is negative. Let's absolute value b, and let's make it positive, because that's really what it does. And so what I'm going to do is I need to type math.abs, and that basically says do the absolute value of b. That's what I'm looking for. And so if I run this, I should have output that is actually +7, because this says do the absolute value of b. So the math portion is telling me to go into the Java library and grab, think of it as the math portion of the library, and within that library, think of this as a book on the shelf, if you will, and grab the absolute value method. And methods are like mini programs, and in this case, the math area of Java already has these little programs written for us that will do things. So math.abs will do absolute value for us. The next one is math.pow. So this is where a lot of programmers in the beginning accidentally think that if they do 2 to the third power, they think that that's what it means. It does not. In order to do exponents, what we need to do is use math.pow. And so actually that 2 to the third that I had, the 2 is the base number, and the 3 is the exponent, 2 to the third power. That's exactly what the x is here. It's the base number, like the 2, and the exponent is the y. And so if I wanted to do that 2 to the third power problem, what I would actually have to do, and I'll output it just to show that that's what's happening, is I would have to actually do math.pow and do 2 to the third like this. That's how I could do 2 to the third power. So 2 to the third, remember, it means 2 times 2 times 2. So the answer should be 8. 2 cubed is 8. And I will print that out. Now notice that it gave me 8.0. Well, math.pow will always give you a decimal answer. So it's pretty important to remember that this will always equal a double. It will always give you a decimal answer. Where math.abs can give you actually both an int or a double, all depending on what you give it. It will return to you what you gave it, because it does just make it positive or negative. So let's talk about square root. Square rooting is going to be very similar to pow in the sense that it's only going to return decimals. So let's do another output, and this time I'll do math.square root. Just remember it's SQRT, and the number that I want it to square root. So I'm going to square root the number 9. Just we'll pick an easy number here to work with. So if I square root 9, we know the square root of 9 is 3. And it's going to give me, though, 3.0 when I do this output, because it always gives a double. Square rooting will always give a double, even if the number is a nice number. If I wanted to find out what the square root of 5 was here, square root of 5, I can put a 5 there, but let's just put the letter A and put that, and that will be a really long decimal, because the square root of 5 is not a nice number. Let's talk about math.floor. Now, math.floor is basically a method or a function that rounds down. It's exactly what it rounds down. It drops all decimals. So in this case, I'm going to show you a couple different numbers here. Math.floor. And let's start with a number that should obviously round down, a number like 6.1. Okay, if I do math.floor and run this one, the last number is the output I'm looking at, and that's 6.0. It rounds down. Of course, it is going to give me a decimal all the time, just like the other things. So math.floor will give you a double all the time. Remember that it means that you are going to round down. It is like the greatest integer function in mathematics. So just to prove that point, if I were to make this 6.8, floor does not round in general. Floor rounds down. It drops all decimals, so it's still going to give me 6.0. It basically just drops the decimal. That's math.floor. Now math.ceil does the other. Okay, it actually does the complete opposite. Okay, math.ceil rounds up. So if I were to put 6.8 in here, math.ceil will round up to 7.0. And so keep in mind I'm adding another line of output. So I'm just looking at the last line of my output screen here. And that one rounds up to 7.0. And to prove that point, if I were to change the 6.8 to a 6.2 and run it, it will still round up to 7.0. Okay, so math.ceil will give you a double, and this rounds up all the time, but it will still give you a decimal even though it rounded up. So the other ones start to get kind of self-explanatory when you look at what's going on and what you're being handed here. But we can also do math.min. And what math.min does is it actually compares the numbers. It compares two numbers that you give it. Now, whatever you give it, it will return back to you that data type. So right now, we have two integers. And so what this is going to do, math.min, is going to compare 3 and 7, and it's going to tell me which one the minimum is, which one is smaller. So that output is going to be a 3 when I run it. And notice it gave me an integer, because I only gave it integers. Now, a few things to mess around with here is what if I add a double? What if I compare an int and a double? And notice now it gave me 3 as an answer, but it gave me 3.0. Because remember, the pattern with Java is it will return the data type, or return the most precise data type that you give it. And in this case, I gave it a double, which is more precise than an integer, more accurate, has more memory. And so this min will return an int or a double, depending on what you give it. Okay, and what min basically is doing is it's just telling you which is smaller. This is not a bad idea if you want to compare two numbers in your program, just to compare and figure out which number is the smallest number of two. Well, the next, math.max, you could probably figure out is basically just the same thing, but it's going to return the larger of two numbers. So maybe I will do the 3 and the 7 this time, two integers, and again, this will give me an int or a double. These are both ints, so it's going to return an int. And this time it will return the 7 for me because that's the larger of the two. Math.round is going to do exactly what it says it's going to do. It's going to round the numbers for us. It's going to round those off. Now, math.round will only return an integer. So if I go math.round, and it's going to round whatever number I give it. So if I give it 5.33 and ask it to round it for me, math.round, round 5.33, I'll run this and it's going to give me a flat 5 here, just an integer of 5. And we'll change this to a number that rounds up just to verify, 5.93. And we'll run this, and that gives me the 6. Now, math.round is nice. It does give me just an integer value, but it's also very important to understand there is another way to round numbers. And currently, math.round is a method that just does it for you. It works its magic. It's like cheating in math class when you use a calculator. But there is another process for rounding numbers where you add 0.5 and cast as an integer. If you do not know that process, I highly recommend that you learn that. That's very crucial. And I do have a video created on that if you are interested in learning about how to round integers and how to round negative integers or positive integers by adding 0.5 and casting. And the last item isn't a method, it's just actually a constant. It's a final variable really in the math this math area of Java. So if you ever want the number pi and you ever want to use it, Okay, you can actually just call it. You can just say, hey, go to the math, go math, and then go grab that number pi for me. So in this case, it's kind of like in a math class where sometimes your teacher told you to use 3.14 for pi. Sometimes your teacher may have told you to use the pi button on your calculator, or to use a certain decimal value of pi. Well, in Java, it's stored for you, and you can just grab it. It's like hitting the pi button on a calculator. You just need to be able to use math.pi whenever you need to access pi. There's a little bit about math methods and how you can use them, or basically how you're just using calculator buttons in Java.